Hello and welcome back to Mrs. Riley's Maths videos. This is a probability video for Leaving Cert and it covers the concept of Bernoulli Trials, which is a new idea in Leaving Cert course. You won't have come across it in Junior Cert. The key idea in Bernoulli Trials is this idea of success or failure, that there's only two outcomes in any of these trials. One is that you succeed and the other is that you fail. Okay, or that you hit a target or that you miss a target, or that the answer is yes or the answer is no. So for example, if you're driving a car and you come to a set of traffic lights, either the success would be that the light is green, the failure would be that it's red or orange. The success might be you get to go through the light safely. The failure would be you have to stop at the light. So any type of Bernoulli trial has to have two outcomes, success or failure. And that's a very important concept to keep in mind. The second property of a Bernoulli trial, and you do need to know these properties unfortunately, the second property is that the trials are independent of each other. Okay, so if you think about tossing a coin twice, the trials are independent of each other. It doesn't matter if you got a head on the first, it's not going to have an impact on whether you get a head or a tail on the second. So the trials are independent of each other. What happens on one trial does not have an impact on what happens in the other trial. The third point for Bernoulli trials is that the probability of success or failure does not change from one trial to the next. Okay, so if the probability of getting a head on the first coin is a half, that's still going to be the probability for the second time you toss the coin. It's also going to be a half to get a head. Okay, if the probability that you go through the first light is a third, then the probability that you go through the second traffic light will also be a third. So the probability does not change from one trial to another. And the final part is that there's a fixed number of trials. It doesn't go on forever and ever. It might be 10 trials or 20 trials or 100 trials, but it's a fixed number of trials. So what are the key ideas there? You've got two outcomes, success or failure. You've got the trials are independent. The probability of success or failure does not change. And there's a fixed number of trials. And those are the key ideas for a Bernoulli trial. Let's take some examples here. So for instance, rolling a dice 3 times, what would be success and what would be failure? We might have to define what success is and what failure is, because obviously there's 6 outcomes for here, but we only want 2 outcomes. So for instance, in a Bernoulli trial, the 2 outcomes might be that success is rolling a 6 and failure is not rolling a 6, so rolling a 1, 2, 3, 4 or 5. So failure is not a 6, success is rolling a 6. Tossing a coin twice, well, it's easier to see that there's only 2 outcomes, but which is success? You'd have to define it and say, well, success in this case is getting a tail and failure would be getting a head. I'm going to do 3 examples. I'm going to start over here because it's a slightly more straightforward example, and then I'll work through the other 2. A fair coin is tossed until a head occurs. So fair coin is tossed until a head occurs. Is this a Bernoulli trial? Let's think about it. There's 2 outcomes. What's success? Success is that a head, okay, is tossed. Are they independent of each other? They're independent, yes, because one outcome doesn't affect the next. It doesn't change. It doesn't matter whether you get a head on the first coin, on the first toss or not. You still have a chance of getting a head on the second. Okay, what's the next one? They're independent of each other. The probability stays the same. Okay, it's always a half to get a head. The probability is the same each time. And is there a limited number of trials? Well, I guess there's a limited number of trials in that what happens is you keep going until you get, well, we've got 3 tosses, haven't we? Sorry, a limited number of trials. Yes, there's 3. The probability the same is a half. They're independent of each other, and the success is a head. Okay, so yes, these are Bernoulli. So, a fair coin is tossed until a head occurs. Find the probability that the first head occurs on the 3rd toss, so that we get success on the 3rd toss. Okay, so what does that look like? Success on the 3rd toss for the first time, 3rd toss for the first time, means that we failed on the first 2 tosses. Okay, so success on the third toss for the first time means we failed on the first two tosses. In other words, we got a tail because that's failure. Okay, so head is success, so failure is tail. Okay, so we got a tail on the first toss, and then we got a tail on the second toss, and remember means multiply, and then we got a head on the third toss. So a tail and then a head. So the probability of success on third toss for the first time will be a half, because the probability of a tail is a half. Probability of tail is a half, so that's the second one, and the probability of a head is a half, which is a half on the third one. So 1 out of 8. Okay, so probability of success was a half, probability of failure was a half. They were independent of each other. There was a limited number of trials, and we knew that success was a head and failure was a tail. Here's a different type of question, one they like in exams. A student takes a 3-question multiple choice test. So there's our limited number of trials. There are 4 choices in each question. She guesses each of her answer. What's the probability that she gets all 3 answers correct, or that she gets the first 2 answers wrong but the third correct? So let's go through our possibilities. Okay, so is it a Bernoulli trial? Is there success and failure are the only 2 options? So there's actually 4 questions. So how do we make a success and failure situation here? If there's 4 choices in each question, then she's got a success if she answers correctly, and a failure if she answers incorrectly. That makes sense, doesn't it? So a correct answer, there's 1 answer, I presume, that's correct out of 4. So success is 1/4 and failure is 3/4. Okay, success is 1/4 and failure is 3/4. Now, she's going to guess each of her answers right, so she doesn't have any prior knowledge. So in other words, it's going to be the questions, for instance, are independent of each other. It doesn't say that any of them are follow-on, so that's good. And the probability doesn't change. It's always going to be 1/4 and 3/4 because she doesn't have any knowledge. Apparently, she's just going to guess. And then, is there a limited number of trials? Yes, 3 questions, so it's a limited number of trials. So we're happy that it's Bernoulli. Okay. So what's the probability that she gets all 3 answers correct? So part 1, all 3 answers correct. That is going to be success, isn't it? So correct is success. So she's going to get the first answer correct, which is 1/4, the second answer correct, and the third answer correct. So it's 1/4 by 1/4 by 1/4, which is 1 out of 64. All 3 answers correct means it's success all 3 times, 1/4 times 1/4 times 1/4. What's the probability that she gets the first 2 answers wrong, but the third correct? First 2 wrong and third correct. So the first 2 wrong is failure, isn't it? So a wrong answer, which is failure, is 3 out of 4, and a correct answer, which is success, is 1 out of 4. So failure is incorrect. So she got the first 2 wrong. So she got wrong, wrong, and then correct. Is that right? So the failure is wrong is 3/4, and then she got the next one wrong as well, which is 3/4, but then she got the last one right, so 1/4. So 3 by 3 is 9 over 4 by 4 by 4, which is 64. Okay. Final question. And this again is one that they like to do. A soccer player has scored 75% of the penalties he has taken in a season. In a penalty shootout of 3 penalties, what's the probability that he scores his first penalty, or that he scores for the first time on his second penalty? Okay. So even though it's 3 penalties, we're just looking at the second penalty, so we don't really need to worry about the fact that there's a third one, because the question is just dealing with the first one and with the first 2 penalties. Okay, let's see. Is this a Bernoulli trial? Is there success or failure? Well, yes, obviously success is to score, and failure is to miss. Success looks like it's a 75% chance, because that's his rate so far. And failure then would be a 25% chance, because they have to add up to 1. or 100%. There's a limited number of trials because there's 2 trials, so that's good. And what else? The shots are independent. Now, you could argue, I suppose, psychologically that if he misses his first kick, he's going to be more anxious to score the second one. But listen, we're going to assume that the probability stays the same and that the trials are independent of each other. Okay, so what's the probability that he scores his first? Probability scores first. Well, obviously, that's just 75% because that's his rate. That's what he's shown himself to do. He scored on the first penalty 75%. What's the probability he scores for the first time on his second penalty? Well, if he scored for the first time on his second penalty, obviously he missed his first and then scored. So that's going to be the probability that he misses, so failure, and scores. So that's going to be 25% times 75%. 25% for the miss and 75% for the score. So 0.25 by 0.75, which is 3/16, which is 18.75%, is the probability that he scores for the first time on the second penalty. Let's just add in a question. What's the probability he scores for the first time on his third penalty? So on his third penalty, what's the probability that he scores for the first time on that? So that means he missed, which was 25%, and then he missed, which was 25%, and then he scores on the third one, which is 75%. So the probability of first success on third penalty is going to be 25% times 25% times 75%, or 0.25 times 0.25 times 0.75, which equals 0.46. So let's say 4.7%. Okay, so there's a 4.7% chance that he will score on the third penalty for the first time. Wow, so he's got a 96% chance of scoring on the first 2. Okay, I hope that helps. Thanks.